Hello everyone, welcome to my channel Cloud and Data with Kaushik. So today we are going to discuss uh, from that machine learning part of this problem statement, and this session is continued with the part one. Okay, I have already discussed and I have already started this session, and now I am going to start from there. Okay, so without any delay we can get started. So first we have to go to our notebook, and I have discussed the concept of label encoder, right? So why label encoder is required and which time are going to apply. So I already discussed. So again I also discussed this thing. So like if you have, I'm also write this thing here, okay, the text box. So if you have a categorical features, right? Means why I am going to use, why I am going to use label encoder, and when I'm going to use label encoder. So the use case is that if you have any categorical feature like color. I already discussed this thing. Again, I'm writing. So like the with categories red, blue, and green. Suppose, okay. Label is the label of this category. The category is feature color. Okay. So this label I have to assign the numerical values. I have to assign the numerical values like 0 for red, 1 that can be for blue, and 2 that can be for your green. Okay. So machine can understood the numerical value, but you and me can understood that this is the red, and that value will be mapped in the ML, right? So that is the reason we have convert our categorical feature like color, and they have the many features like red, blue, and green. This is a label we have to convert. So that is a theory part, right? So before going to apply this thing in our actual algorithm, actual problem statement, first we have to just check how it is working. Okay. So yes, it's connected now. What I'm going to do, just scroll down, and for only label encoder concept. Yeah. This is a concept. I'm just going to create one separate static data, and then I'm apply this thing so you can understand. And after that, I will apply in the our problem statement, right? So like you have data. Suppose you have data. Data can be anything, right? Like color. I told color, and their label is there. Suppose this is my label and this is my key value here, right? So red, comma green, comma blue. Okay. Suppose red and green. Okay. This is your one data set. Suppose you have get this data set, right? Then you have create the data frame, and I have already pandas we have installed, I think, and already we have add this library, and you have to create the data frame. Okay, so this is my data frame data. So I just going to apply this data set, and I have to create the data frame with the data set. So create the data frame with the data. Okay, and this is our static, or you can see, or you can fill this sample data. Okay, this is not related and not related to our project, not related to our project. Okay, this is not related, only associated with the problem statement, associated with the concept. Okay, so just I have created the data frame with that, with the data. I just, you can, oh, PD is not defined. That means I have to run every cell. So it was restarted. I think that. So if this kind of situation happen now, so your code is there, just go and go to the runtime tab and just run all. Okay. So automatically it will run each and every shell, right? So like executing one by one, you can create runtime and go and click the run on cell. Okay. And then it will be working. Just a minute. And you have to allow the access for your drive. Yes, I hope it is done. And I have to wait for the execution of other cells and it will be working. Okay. It's now, I think, working. Yes, you can see each and every cell is working. So DF is there. So I can get the DF also. Now you have to initialize label encoder. So first we have to import. So you have to import the label encoder. Okay. So same from scalar dot pre-processing, import your label encoder. Label encoder. Okay. You have to import this. And you can search this thing. Na? Just write in your Google label encoder. Label encoder is scalar. Okay. Label encoder is scalar, and it will redirect to the same page from your official website. Okay, scalar.preprocessing.label encoder. Everything is there. You just go and I copy this line, same line I have already created, and you have to initialize this label encoder. Like you have this value, right? You have this value. Label encoder, you have to import the label encoder libraries. Okay. So step by step I'm going to do. Okay. So this is done. After that, what I'm going to do, I have to initialize the value. Like LE is equal to label encoder. So they have initialized. Okay. So they have initialized this value. Just make one comment. Init the label initialize the label encoder. Okay. So you have to initialize this value, and then once it's done, just take one cell and you have to create one variable or one cell or column name, right? Color encoded. You have to encode this, right? You have red, green, blue, this category. You have to convert it in the numerical value, right? Like label encoder, or LE. You can see LE because you have to LE.fit. That's all. Fit underscore, just a minute. LE.fit transform something is there. Yes, fit transform. And you have to transform your EF, and where you have to add, because you can see your DF first. So just go and write df.add. Yeah, just display your data frame. Just display your data frame. Okay. Now you can see only color is there. So that means df color I am taking. Over here, I have to take df color. COLR. So you have to encode this thing, right? Just to encode it, taking one column, and that is color encoded. Okay, put it and create the label encoder. Create the label encoder. So I hope you can understood, and now you can check your DF. You can check your DF. You can see the label encoder value already created. Now red is 2, green is 1, blue is 0, and this value is coming, right? Red, green, blue, red, green. I have taken red, green, blue, red, green. So color encoded is coming 2, right? Automatically the machine has identified this color encoded. Red, they can identify 2. Green, actually 3 colors, red, green, and blue. Okay, red, green, same, red, green, blue. So green is coming. 1 minute. Yes. And we have applied the feeds transform method to the color column, right? We have applied this thing, and to getting the and part to perform the encoding, and the transformation of data frame, it looks like something. Okay, so machine can understood this way, 21021, in this way machine can understood. So this is the concept of label encoder. Okay, you have some category and you have to import the label encoder, then you have to convert this category into the numerical features. Numeric machine only. Red means they have understood 2, green means 1, blue means 0. Okay, that is the reason they have added this value. So I hope you can understood the concept. So when I'm going to use, if you have the categorical features and if you want to transform into the numerical values, right? Because for calculating part of machine learning, they have to convert it in the numerical values. Okay, and these values totally machine can depend. They have provide this value. Okay, so I hope you can understand the label encoder. Now, this concept I'm going to apply in my actual problem statement. The label encoder problem statement means in my Mercedes-Benz problem statement, right? So just scroll down and just take one code, not here. I hope you can understood, right? This up to that there is no problem. If you have any doubt, so please let me know and I will try to address this concern. So just one code cell, okay? And what I'm going to do, I'm going to apply the label encoder over there, okay? And then you can also understood how it has been working in the actual problem. So this is the concept, right? So this is the concept. I just wait 1 or 2 minutes. So if you have any doubts, so please let me know. And then I will proceed with the label encoder part, okay? Now I'm going to start the actual use case. Okay, so we have that features like train data. In our data set, what? Train data, right? Train data. And I have to create one feature. This is the column, or this is a variable where I'm going to first I'm going to use train data, and always I can want to drop. Okay, I can want to drop y, and so first let me check the train data, how it is look like. So just write train underscore data, train underscore data. Okay, or head, just take two columns. Okay, just take two columns. So ID and Y. This is not required. I'm going to drop this column. Okay, I don't want this thing, so I can drop. The easiest way you can drop, just like your data object, data frame, and yes, I already discussed. So if you want to take the type, na, what type of data this is? This is pandas data frame or not? So you can just go and paste type, and you can see it's a pandas.code.frame data frame. That means my object creation is done successfully. I've created the pandas data object that I've already discussed. Again, I'm going to repeat these things because you can understand step by step. Okay. So train data underscore feature, and you have to drop this column. So write columns is equal to what column I'm going to drop? ID, comma, Y. Okay. So it is not necessary that you have to write in this way, means that order you have to mention, right? I can write also this way, Y, and I can also write this ID. Okay. And now execute the cell. So I have removed this columns train data feature. You can see remove the columns like Y and ID. That has been removed. Okay. Just copy this feature and you have to print. So you can see there is no ID and Y column. Also, you can take head, just shoot the two rows over there. Okay. So there is no ID and Y column, right? Next, what I'm going to do? I have to create one target. So train underscore data underscore target. Copy means for your safety, you can copy this thing. Okay. So if anything is happened unavoidably, so you can copy this thing. So if you have this backup, it's a backup. If any accident happens, like in your train data is miscalculation happens, so you can copy, you can refer this object. That is why I already created one backup of this data. That is the reason I've taken the copy. Okay. So train underscore data underscore target. So train underscore data dot Y. Yeah. Let's see my target column first. Okay. And this is your target column, right? Y. So train data dot Y. So you have this thing. Okay. So you have this value, train data target. Now you have to take this I already shown this feature, right? Train data feature. So do one thing, you just upper this thing and feature. So it will be okay. So train data target, you can have this thing. Train data, sorry, otherwise it will not work. So train data target, and then you have to feature train data feature. Okay. So if I'm not going to add the any variable, so it will print 5 rows. Okay. So this is my train data feature, and target already shown you. This is the target, and you have to create the head. These two things I already shown to you. So your train data target and train data features are ready. Okay. Now you have to take the shape. How many actual train data feature? How many rows and column? Okay. Take the shape of your train data feature. Train data underscore feature. Now what I'm going to do, just copy this line and dot save. Just save, and it will provide the values, rows and columns. Okay. Now write train data dot save. Just execute the cell. So this is 4209364. As of now, we are okay. And also take the shape of your, just copy this line and do one thing. Instead of writing the comment over here, take one F string, and inside the F string, you can add this line. String literal, like in the, this is called string literal. All the things you can write at a pace. Okay. And just copy this line, paste, take the shape of your train data target. Okay. Train data target. And execute. So one is 4209364 and 4209 for your train data target. Okay. Now we want to see the 5-point summary of those data frame, that is object. Those columns, that is object. Okay. So take, have a look on your 5-point summary with the help of describe method. With the help of describe method. This is the method that will tell you that 5-point summary. So just copy train data feature dot describe, and you have to include my object and just run it. Okay. So you can see count, unique, top, frequency, these values you can get. Now, next step, what I'm going to do, I have to transform with the label encoder. Same thing I'm going to apply. The label encoder transform method that I've already shown to separate concept in separate example. Same thing I will apply in my problem statement. So LE already I'm taking label encoder. L is there, again you can write So train, or you can write not required. So really was already mentioned earlier. Right? So like train data feature, and you have these columns x0, right, is equal to le dot heat transform no, this is describe method. It will the numeric value, the statistical record they will provide. Okay. And now transform, you can write train underscore data underscore feature dot this value. And up to 8, x0, x1, x2, x3, x4, x5, x6, x8, x1, that will be your x1. So train data feature, let's have a look. 2 rows dot head 2. Okay. So now you can understood. This is a categorical value k, v, at that going to convert in the numeric. Apply the label encoder. Okay, and that is the numerical statistical records describe the 5-point summary it will provide. This is the statistical record, it will provide the 5-point summary. Okay. Now copy. So x1, x2, x2, copy x3, that will be x3, and x3, x4 is there, right? X4 and x5, x5, this column I have to take. And after that x6, 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 and now last is pending, that is x8. This is not 0, this is O. All the categories, you up to that x2, x0, up to this one, na, this is the category. You can see this is not 0, this is O. That you have to convert in your categorical features. Okay. Numeric category to numerical features. So x8, and here you have to convert it x8. Now just run it, right, apply the label encoder, and just run it. It's done. Label encoder creation done. And just take a look on your data dot head. Only 2 rows because I have to check this is converted or not. Yes, now you can understood 32, 23, 17, 18, 14, right? K is converted 32, V is converted. So this is the label encoder I have applied. So machine now can understood the numeric value. But we have mapped this numeric value with my categorical value, right? Then I will apply the other algorithms part after creating the label encoder. So this very important features. Whenever you show in your label in the category, that kind of things, category is there and you have to convert before applying to the machine learning algorithms, right? So that is the reason I apply these things. Now I have to perform the dimensionality reduction, because in the problem statement you can see. So the problem statement, I have to apply the dimensionality reduction. This task is pending. So now I'm going to apply the dimensionality reduction. Dimension, actually dimension is there that I have to reduce. It's medium. So label encoder is done, and now I'm going to perform this thing. So go and take the text and you have to perform this thing. Dimensionality reduction. Not perform, just easiest thing. No issue. So again, before going to apply on my real problem statement, first we have to understand the concept. Why I am going to use this dimensionality reduction. And before going to starting this problem statement or this concept, so I just wanted to know if you have any doubt. So please let me know. I'm just wait 1 or 2 minutes, and then we can start. Okay. In between, if you don't understood any concept, so please let me know this thing. I will again explain this. No issue. So okay, let's start. So first understood the concept I'm writing. When I'm going to use, right? So you can say dimensionality reduction is a technique in machine learning to reduce the number of features or variables. Means you have lots of numbers and lots of features or variables, right, in your data set. While if you see, so I'm writing this thing so you can understood. So just write dimensionality reduction is a technique in machine learning to reduce means decrease, to reduce the number of features, or variables in your data set while preserving its important characters. Here. So it can be beneficial for various reasons. It can be beneficial for various reasons. It can be beneficial for various reasons like improving model performance. So it's a reduction technique, right? You have to reduce. So reduction means reduce, you all know. So it's a reduction technique. What I'm going to reduce the number of features or variables in my data set. So we have large number of data, right? So you have to remove these things while preserving its important characters, but we have to preserve its important characters. So when I'm going to apply this thing, it can be beneficial for various reasons. Like you have to improve the model performance. You have to reducing computational complexity. Computational complexity and identifying the key features. Yeah, and that is the time we are going to use. Means for getting this kind of benefits from my data set, I am going to use dimensionality reduction. So there are many methods of doing these things, but machine learning language or data science language, one common method or popular method in data science language, very easy term I'm going to use. So data science can understood in data science language. One popular method. So one of the popular method for performing dimensionality reduction is PCA. I'm going to use this PCA in my real problem statement. So name is principal component analysis. The full form of PCA, principal component analysis. I hope you can understood. So you can write PCA or principal component analysis. Okay. Now what I'm going to do, I have to apply this PCA in the small data set. You can understood. So iris data set, I'm going to apply this PCA. So just write iris is inbuilt data set of scalar. I'm no need to go the CSV file and that. Scalar has many inbuilt data set that you have to know. So just write scalar import the necessary, and this is not related to my actual problem statement. This is the concept, and this concept I'm going to apply for understanding purpose for a small data set. Small data set, okay? And this data set is from scalar library iris data set. Okay. And then when I'm going to understood this process is good, means we can understood these things, right? Then we can apply, because concept and these things first we have to understood before going to apply in our actual problem statement, right? So import the necessary libraries. Scalar dot data set. You have the data set, right? data set. Scalar dot data set and import your load iris. You can say breast cancer data set, diabetes data set, load digit data set, load files. These all are the data set. I am not going to use any CSV file. This is the inbuilt data set. Okay, load wine. So this prefix name is load. Whatever load is there, you can see. There are many number of data set is there. So here I am going to use the iris. Just go and select iris. Iris dataset is there. Pandas we already installed. We already configured this libraries. Now PCA. PCA from where I'm going to import and consider. So just only one stop store, right? Just write PCA in scalar. Everything is there. Go in the website scalar.decomposition.pc. So this is linear dimension reduction. You can see this is the official page of the PCA. So you can refer this thing. First, go to your site and just adding this link. So it will be easily understood when you practice these things, right? So go there and you can see principal component analysis, linear dimension reduction using singular value decomposition of the data. To project is a lower dimension space. Same thing, right? I'm going to use. The input data is centered but not scaled for each feature before applying the SVD, means singular value decomposition. And from this library, use the PCA. Okay. Everything is there. Also examples they also provide. PCA example. Okay. Also you can do these things. Just before going to apply the iris dataset, you can also do these things. You have to create your own array of data, 2-dimensional array of data you can create and you can apply these things. Okay. So just go and write import numpy as array over here. Just take one quote and just copy numpy already there and you have to import. This is the PCA. That's right. Why I'm going to add NP? For creating the data set of numerical data set I'm going to create. Every time data is not coming from the CSV box. Data is coming anywhere. You have to convert ultimate goal the data frame. Anything is there. So before going to apply these things, we have to know how to convert these things the data frame object. Once you have the data frame, these are data source, CSV, PDF, image source, audio file, these all are the data source. And you have to convert some methods, right? As per your business case. Not all time you have to convert in the CSV file. It's required as per the business case, we can take the decision, right? So here you can take X in array and these all the data set, data source from the data. So this terminology we have to understand. Okay, then your idea will be clear. These are the data source and we have to read this data source with the help of pandas, PD's line. So now I am taking np.array. Just write PCA so you have the PCA, you have to initialize the PCA. This is the PCA and n components too. Now what I'm going to do, PCA.field. Just execute this thing. So PCA is there. In components, you have to create this principal component analysis, and then take the code and do the print. This value you can print over there. So you can see, and now print the singular value. Okay, you understood? And now you can do for your, if your PCA like up to 2 components you have to take in, right? And HBD solver is full. There are different HBD solver. Okay, so n components, this class uses this methods. So it's a how much time you have to apply these things, this NPA method, right? In component method. Same thing is there. If you have this PCA, then different values are coming. So you can go and check. So you can understood. This side is very helpful. Everything is there for your reference purpose. You can use it. So now I'm going to apply this thing in my iris dataset that I told already, right? Iris dataset we already imported. Yes. Now load iris dataset as your example. Iris equal to load underscore iris. And your data would be iris dot data. And your target equal to iris dot. So first I take the data. Print if statement iris data. One data. So load iris, that means I'm not going to execute this. Just a minute. Just execute yes. And now it will be working. Now it will be working. You can see it will be working. Okay, this is the data. And you also can print the target. Take one column on cell, that is print your iris dot target. Okay, is the target. Now you have to create the data frame because this array format is coming, right? 2-dimensional array, the array format is coming. So you can take the print, right? You can also write the print, or you can also write this type of data. First check what type of data it is. One type of data. Type of data. You can write type numpy.ndl. Okay, this is the array, and this array is inspired or coming from the numpy. All the array concept. But iris target also is there, right? And now I told you that data frame we have to create, and all things will be coming inside the data frame. So now I am going to create the data frame for better visualization. So write df is equal to pd dot data frame. We have the data frame, data frame, data frame. Now I have to create the data frame, right? You have to supply the data and you have to supply your columns, and you can write iris dot features, feature underscore, sorry, feature underscore names. Now my data frame will be created. Okay, so you have to take the columns and you have to take the data. And next I'm going to write target. EARZ target. First you have to check the data. Our DF is ready. DF dot head. This is the two columns, two rows is coming, right? And we have to add one column, target EF target is equal to target. Yes, right. Okay, it's target not fit, right? So we have to create the target first. Target from your iris dot target. And then you have to write. Yes, so target is ready. Now again check the total DF. Again check the DF iris data set DF. Or 8. Just take two rows. Now you can see target is added over here in the data set, right? You have to combine these things. Now you have to apply the PCA. Now we can apply the PCA. Now we can write we have our data frame with the PCA, principal component analysis. So I have PCA underscore DF data frame, and to create the, this is a variable, right? So PD data frame. You have to create PD data frame, and you have to supply your data, and this time your data would be PCA, right? So what I'm going to do, I have to apply my PCA. Apply my PCA. Apply my PCA. How we're going to apply this PCA? So you have the PCA. I already discussed PCA in components equal to 2 and principal underscore components is equal to PCA dot fit transform your data. That's all. Fit transform your data. And take have a look on your principal component. This is your array. You have to feed these things and you have to create your data frame. Okay. Your data is there like principal component. Data is equal to your principal component, and you have to add your columns is equal to like PC1, PC2, and you have to create this PCDF, right? Your PCDF is ready. You can take a look on it, how it is look like. PCDF. Okay, it's converted into the data frame. You can see it's not coming as an array. It's coming as a data frame, and there are 150 rows and 2 columns. Okay, and you have this target. So you have the target also. Go to code, and you have the target also. PCDF target is equal to your target. That's right. So you have to add a target over here, right? Now you have to see the original data. Print. We have to see my original data. Original data means before going to apply PCA. Before going to apply PCA. Okay. This is your data. Print. Let's write print, and your df dot head. Okay. And we can write df dot head to all our data frame, no issues. We have the data to remove this thing, print statement. So you have the PCA. This is the original data, and now after applying that dimension reduction, you can also check PC underscore DF in dimension reduction and dot get. Just take 2 rows and your 2 data set is present. You can see we have optimized this thing, right? Reducing, but optimize the variables for computational purpose, right? So this is the original value, and this is the after applying the PCA. So after applying the PCA. Okay, I hope you can understood up to that for the principal component analysis. Now, next, what I'm going to do, this concept I'm applying my original problem statement, means this problem statement, right? I hope you can understood. And in the next, this video, I'm going to close over here, and because this lengthy video is not working for each and everyone, so I will create another one, and there I am creating that PCA in my original data frame, means original problem statement, right? So I hope you can understood this concept. If you have any doubt, so please let me know, and we'll address your concern. And please subscribe my channel. That will help me to grow, and in this way we can learn and grow together. Thank you everyone for joining this session, and the next session I'm going to continue from this session, continue this session from the next session, and there you can, I am going to apply the PCA in my problem statement. So thank you everyone for joining. Thanks.